Very good evening to all of you. Am I clearly audible? Please mention in the chat window if I'm audible to all of you. Thank you, Aditya. I hope I'm audible to all others as well. Okay, so the discussion topic today is that how do you get rid of your fear of higher math in the exams like the DUJAT and IPMAT? So the point is that some of you must be from the background in which you have not taken math in 11th and 12th. And that really creates a fear in your mind that how will you be able to handle the typical higher math questions in IPM? DUJAT, of course, is open for students who have taken math in 11th and 12th. But basic thing what you need to understand is whether you have taken math in 11th and 12th or not, irrespective of that fact, you should be in a situation to understand that the category of higher math questions that are asked in both these exams are not very theoretical questions. They are not like you have a big solution or a big theorem. Of course, these are competitive exams in which there are objective type questions, and max to max you have a short answer question. So the questions are not very subjective in the manner, right, the way you have in school. And the second very important point is that all these questions can be very easily managed with certain shortcuts, certain tricks, and certain idea of the concept that the particular topic revolves around. So with that conceptual knowledge in your mind that, there are tricks, there are shortcuts, you don't have to always go into the technicality of the topic into that much of depth as you would have done in 2 years of 11th and 12th, right? So obviously, why this fear comes in your mind is because of the fact that you start feeling as if you have to complete those 2 years of mathematics of 11th and 12th in just few months. The answer is no, you don't have to. Because as I said, the category of the questions that are asked in these exams are very specific category questions and a very specific category of questions also in which there are shortcuts available, there are tricks available. It's just that you need a proper guidance on the kind of shortcuts which are there, the kind of tricks which are there, and of course, the basic concept. So how do we start preparing for higher math? First of all, you need to be aware of what topics you need to cover. So basically talking about DUJAT, it's almost everything which is there in 11th and 12th syllabus, right? And of course, a little bit of 10th part as well, like trigonometry. For IPM, there are very specific topics which are there. Specific topics like trigonometry is there, matrices, determinants, little bit of calculus sometimes is there in the syllabus, sometimes it is not there. But things which are very typically there every year are logarithm-based questions, trigonometry-based questions, and questions from matrices and determinants. These are 3 specific topics which are normally there, right? And as I said, DUJAT anyways is open for students who have already taken math in 11th and 12th. So obviously the expectation bar goes a little higher in DUJAT, but even then, don't worry. The level is not as high as IIT exam, okay? So the level of difficulty is very much manageable. All you need to know is the tricks, the shortcuts, and the basic concepts. So for that, we will always be there to help you out, because that's what all these sessions will be all about, that, what are the shortcuts? How do you handle a question using options? How do you not go into the too much of depth of the question, just quickly get the answer and move on to the next one. Because understand, the way you take school exams and the way you take these competitive exams, there is a huge difference. In a school exam, there is always a reason to be mentioned. The steps are to be justified, and there are too much of calculations and reasoning that you have to mention in each and every step. Here, obviously, all that is just a rough calculation that you're doing, right? All that goes as a part of rough work. All that matters is you marking the right option. So if you can mark the right option without actually getting into the depth of the solution, and by just quickly thinking of the shortcut trick, so obviously you end up saving on 2 things. 1, that you increase your attempt. 2, you increase your accuracy. And what is better than that in any competitive exam? Because, the struggle, or I can say the success mantra in all these competitive exams is just the combination of 2, that your accuracy doesn't get hampered, and even then you have a very good attempt. That is what will make you successful, right? But as I said, for all that, you definitely need some guidance in terms of what is the basic concept. That's what is the first ladder. Then coming down to, is there any shortcut trick? Third is, can I use options? Can I just avoid solving a question in too much of detail? So all that is a process of learning that you will have with us. Okay, so till here, any questions? So I've kind of introduced the topic for today to all of you. Now let's just quickly see what is this higher math all about. So the topics that I've listed down for you are the common topics for both the exams, and the most commonly used topics which are there in all these exams every year. Okay, so these are like consistent topics which you will definitely find. So let's move ahead in this presentation. So what comes under higher math? As you can see, a lot of geometry, a lot of 3D, a lot of Venn diagram based questions, probability, trigonometry, solving equations, all that is a part of higher math. Calculus is the first important topic that you need to be aware of when you are talking about higher math. So what comes under calculus? Calculus basically means that anything to do with functions. What are functions? Of course, that's a very conceptual topic that you will learn with us. So some of you might be already aware of what functions are. Some of you might not be aware of. So that is the basic concept you need to be starting your topic of calculus with. That is, what is a function? Now, after having understood what is a function, you talk about, its maxima, its minima. You talk about its the kind of a limiting value that it can have, integration, differentiation, sometimes in there in IPM, sometimes it is not there in IPM. So differentiation, integration is a topic which is not very consistently asked in IPM, but DUJAT definitely asks a lot of questions from differentiation and integration. For IPM, the part of calculus which is very important is the topic of functions, as I mentioned. And the other part of calculus which is very important for IPM is those maxima minima questions. Okay, so again, those maxima minima questions have a very simple trick that you can apply to make your questions look very, very simple. Okay, so this is the first topic that I had to share with you guys. Okay, any problems till here? You're clear with what calculus is all about, right? Okay, let's move ahead. Matrices, as I said, is the next important topic that you need to cover. So what are matrices? What do we do with matrices? Is there addition, subtraction, multiplication possible? What is inverse? What is the order of a matrix? So all that, again, is the concept that you begin with. And then the questions based on matrices are very typically repeated kind of questions. Very simple, theoretically twisting questions, okay? Not like, a big question given to you, finding the inverse and, doing adjoint and things like that. Not that complicated stuff. Something very simple to deal with the theory part. Then the next topic, which is very important, is logarithm. Again, logarithm, a lot of people feel that it is full of so many properties to remember, so many steps to remember, a lot of things, a lot of log values to remember. Don't worry, anything like that. You don't have to remember any of the log values. You're not supposed to use log table. Nothing like that will be there in your competitive exam. All you have to apply is one single trick that works for almost all the questions, right? With 3-4 properties. So I'll handle logarithm questions for you in the class today itself. And I'll tell you what is that one shortcut trick that makes every question of logarithm become very simple for you. Then trigonometry, and not just direct trigonometric identities, but its application in the terms of angle of elevation, angle of depression kind of questions. Okay, so this is one topic which you do in class 10th. So almost everyone is aware of this topic. So this is one topic that I will be covering today. Right. So I have listed down the topics for you, the most important topics. So trigonometry is something that you can definitely not ignore. And the plus point is trigonometry you have already done in class 10th. So but of course, the entire trigonometry will not be needed. So do not worry anything about like that. You will have to cover only a specific part of trigonometry, that too with very specific steps of calculations, not very long questions. Its application for angle of elevation, depression, those height and distance questions is very, very important. Logarithm, you will see for yourself in today's class that one single concept, and that's it. The topic becomes very simple. Should we start with some questions now? so that you get the insight of what I've been talking about. What are these topics and why are the questions are very specific and they have a shortcut, things like that. Anyone has any query, or should I go ahead with the questions? Okay, so let's begin with the questions then. Now, my single request to you guys is that you will be solving each and every question. I want everyone to participate, to answer, so that I see how much you understand and what level you are at right now, so that I will be able to guide you accordingly. So please do participate in answering. Do not worry about your answer going wrong, doesn't matter, right? But keep answering whatever you get the answer as. A very simple question to begin with. I'm expecting a quick answer from you guys because it's a very simple question. Okay, Tanishka says it's cosecant theta into secant theta. Okay. Anyone else has any other answer? Okay, Aviral says it comes out to be a constant 1. Ishika says the same answer. It comes out to be 1. Now, look at it. Trigonometry, a lot of people find very complicated because of the simple reason that it has too many things to talk about. Sine, cos, tan, cosecant, doesn't matter. You can always make the questions, at least which you are going to see in these exams, by making it very simple, by writing everything in terms of only sine and cos. Okay, now cosecant theta. What do you mean by cosecant theta? What is its reciprocal of? Cosecant theta is reciprocal of which number, which trigonometric quantity? Yes, anyone? Cosecant theta is reciprocal of which trigonometric identity or trigonometric? Yes. So it is reciprocal of sine theta. Very good, Harshit. And then there is a sine theta here. The other one has secant theta, which is nothing but reciprocal of cos theta. So this term is like that. Tan theta plus cot theta. Tan theta is always sine theta upon cos theta, and cot theta is cos theta divided by sine theta. I have transformed the entire question in terms of sine and cos. Now, what happens in the first bracket? If I take the LCM, the numerator is 1 minus sine square theta divided by sine theta. In the second bracket, it is 1 minus cos square theta upon cos theta. In the third bracket, if I take the LCM, the denominator is sine theta into cos theta, and the numerator is sine square theta plus cos square theta. Now, what is the advantage of converting the entire question into sine and cos? We use the famous trigonometric identity that whenever you have sine square of theta and cos square of theta getting added, it is always equal to 1. It's a very important trigonometric identity, which I wanted you guys to revise through this question. Now, using this property, this number is just 1. What happens to the other values? What is 1 minus sine square theta? Using this property again, it is cos square theta. So this one will become cos square theta. Again, using the same identity. What is 1 minus cos square theta? It is sine square theta. What happens next? This cos square theta cancels with these two. This sine square theta cancels with these two. What are you left with? Nothing other than 1. That becomes your answer. So what did we use in this question? We just used one trigonometric identity, that is the sum of sine square and cos square is always 1. What was the other thing that we applied? Cosecant is a reciprocal of sine. Secant is a reciprocal of cos. Tan is nothing but sine upon cos. and cot is nothing but cos upon sine. So if you know this much, you can solve every trigonometric question with just sine and cos, and using just one identity keeps coming to you in every question. Is that clear, everyone? So if you struggle with trigonometry, this is the tip that will work for you. Convert everything in sine and cos. Remember one important property, and that's it. That will be enough for you to get the answer. Anyone has a doubt with this question? So good, I could see that a lot of you gave the answer as 1, but yes, few of you gave the wrong one also. So I'm sure now it is clear to all those who gave the wrong answer. Okay, let's move ahead to the next question now. Apply the same trick. If you are not comfortable with trigonometry, convert everything to sine and cos. Okay, so Tanishka says 1 is the answer for this question. Harshit has also given 1. Prem has also given 1. Raj also says 1. Okay, great. So I can see most of you giving the correct answer. So as I said, convert everything to sine and cos. What is 1 plus tan square theta? If you know the direct relation, 1 plus tan square theta is secant square theta. So if you know it, then it is even comfortable for you. Combine these two brackets. What made me think of combining the two brackets? Because of the famous formula that is there in algebra, 1 minus something into 1 plus something is always 1 square minus sine square, right? So it's 1 minus sine into 1 plus sine. So it has to be 1 minus sine square theta. And we just did this in the previous question. What is 1 minus sine square theta? It is cos square theta. And I also used this in the previous question that secant and cos are reciprocals of each other. So if they are reciprocals of each other, what should you get the answer as? You should get the answer as 1. Now, some of you might not be aware of this identity that 1 plus tan square theta is secant square theta. You don't know it. Doesn't matter. The other tip which I gave you was convert everything to sine and cos. So if you do that, 1 plus tan square theta, if you are struggling with this, you will first write it as sine square theta upon cos square theta. Then by taking the LCM, the numerator becomes that famous identity which is always 1, and the denominator is cos square theta, which is nothing but secant square theta. Or you can even leave it as 1 upon cos square theta, because ultimately I know that the other two brackets will become cos square theta, so it will cancel out to give you 1 again. So that's another way of solving the question, only for those who are not very comfortable with remembering the identities of tan and secant. But yes, they are comfortable with remembering the identities of sine and cos. So that becomes an advantage for you. Got it, everyone? So again, a very simple question. Let's move ahead. Now we are moving on to log-based questions. And I promised you that every log-based question can be handled with just one single trick. What is that trick? Let's talk about it. So that trick says that whenever you are solving questions of log, remember, log is a function. It has to have some meaning associated with it. So log has 3 numbers associated with it. If you say that you are looking for log of x to the base of y is equal to z, it has a specific meaning associated with it. Otherwise, what is this log? What does it do for us? So the definition of log itself is that trick I was talking about. What is that trick? Does anyone know? How are these 3 numbers connected by the property or the definition of log? How does log connect these 3 numbers? Anyone aware of it? You can always unmute and tell me. Log of x to the base of y is equal to z gives you which relationship or connection between x, y, and z? Who would like to tell me? Harshit, Ishika, Prem, Aviral? Okay, Tanishka has answered it. Z raised to power Y is equal to X. Does everyone think the same thing? Tanishka has answered it as Z raised to power Y is equal to X. Do you all agree with this or not? At least just say yes or no, or else you can always give your answer. No, it's not. Okay, now Tanishka herself is changing it. Okay, so it's Y raised to power Z that you wanted to say, Tanishka. Okay, now she's changing her answer. Y raised to power Z is equal to X. Is this what you are trying to say, Tanishka? Yes, so this is the correct version of the meaning of log, okay? And trust me, if you know just this much, you are 90% done with the topic. So remember it. Log of x to the base of y is equal to sid. What does it mean? It basically means that this number in the base, when it is raised to the power which is there on the right hand side, it should match with this number, okay? If you know this property, or actually it is not even a property, it is just what log means to you, then you are done with solving a lot of questions. Let's go to the question now. This is what I had given you the question as. So let me just remove this. This is the question. What is log of 256 to the base of 4? What did we just discuss? The answer here is such that when this number is given this power, it should match with 256. So what do you immediately ask yourself? Don't apply complicated properties. Just ask yourself that 4 should be raised to what power so that it becomes 256. This power will be my answer. So remember, the base is raised to a power, and that power is your answer of log, which makes it become this number. So now can you tell me which power of 4 will make it 256? Of course, yes, correct. 4 raised to power 4 is 256. So this answer that you're looking for has to be 4. Is this clear, everyone? Yes? Okay. Answer this then. What is log of 8 to the base of what should be equal to 3? What should this number be? Correct, because now I'm asking for, this is my missing number. I know that the power given to it is 3, and I want the answer to be 8. So which number has its power 3 as 8? That number is 2. So the missing number is 2. Okay, so just remember, every log question can be handled by not getting into very complicated situation, by just telling yourself that the number in the base, when raised to the power which is there in the right hand side, will always become equal to this main number. Okay, let's take one more question. Use the property. This number is missing now. Yes, Aviral. You want to answer the question? Okay. Aviral says it is 8. Anyone else got the same answer? Very good. Harshit also got the same answer. How about you, Rahul? Prem, Raj? So very good. You have given the correct answer, Aviral. And Prem, Harshit, you all have given the correct answer. Great. So what did we talk about? This expression means one single thing to you. What is that? 32 is the base number raised to the power 3 by 5 should match with x. Now I just need to simplify this. What is 32? 32 is 2 raised to power 5, and there is another 3 by 5 in the power. So these two powers will cancel out, and the answer becomes 2 raised to power 3, that is 8. So the value of x that you were looking for is 8. Now every time you're not supposed to do these steps of calculations. Why should we waste our time? It's not that we are taking a school exam in which the calculations and the steps will matter. Just quickly remind yourself in the oral calculation rather than getting into writing everything. So this I did for those to understand who could not solve the question. But yes, you can definitely handle these questions orally. How? You will think in your mind, I have to take 32 raised to power 3 by 5. Now 32 is 2 raised to power 5, so that 5 will cancel out. I will be left with 2 raised to power 3, so the answer has to be 8. You need to be that quick with these questions, okay? And it's not difficult, I'm sure, after having understood that log basically has one single meaning, that is y raised to power z has to be equal to x. Just learn this and you can manage 90% of your questions. Of course, the remaining 10% questions are based on properties. So let's now discuss properties of log. So I'm moving back in the presentation so that we will be able to solve this question. What are the basic properties of log? I'm asking you some properties, you will have to answer it. What is log of x into y? Keeping the base same. So I'm not writing the base again and again. Log of x into y is what? It is log of the first one plus log of the second one. So you remember it like this. Log of the product is log of the first plus log of the second, keeping the same base. So if the base is a here, it is a everywhere. What is log of the division? Division also has a property that it is log of x minus log of y. Okay. Then another very important property is if you have log of x to the power n with some base a, this power can always be brought down and it can be written as n log of x to the base of a. So power can always come down, okay? And if you have log of x to the base of x, now I don't even have to mention this as a property. We've already discussed that the answer that you are seeking is basically that x should be raised to what power to make it x? Obviously power 1. Okay. So these are the common properties that come into picture when you're solving the remaining 10% questions that I was talking about. Everyone clear with these properties? Thank you, Mayank. Thanks a lot. Okay, now I have one question for all of you. You will have to tell me what property opens log of x plus y? What is the property for opening log of x plus y? How do you open this bracket? So a silence here means that it's good for me that you're aware of the fact that there's no such property. Please do not ever get confused that sum is related to product and product is related to sum. We don't have any such thing, okay? There is no property that opens this bracket. What you have is a product gets opened as a sum. Vice versa, it is not there. I've seen a lot of students getting confused that this opens up as log x plus log y. Some say that it opens up as log of x into y. There's nothing like that, okay? We don't have any property for sum. We don't have any property for difference. We have a property for product. We have a property for division that we have already discussed, all right? Now, keeping this in mind, this we have already solved, this we have already solved. Now, this one needs to be solved by you guys. So this is additionally making use of the properties that we just discussed. You are given a value. So that's what I said. You don't have to learn any values. It will be provided to you in the question. Using this value, you have to solve this. You have to solve for what is log of 160 to the base of 10. And I've already given you a hint that this question will be utilizing some of the properties that we have just discussed. Yes, any answers? Okay, Tanishka says it is 1.204. Tanishka, I think you made some small calculation error. I think you forgot one part which was to be added. Anyone else has an answer? Yes, Piyush, Mayank, Rahul, Aviral. Yes, Tanishka, very good. Now you have given the correct answer. So can you all see? Tanishka has given the answer as 2.204 and that is the correct one. Let's see how. So the correct answer is 2.204. How? That needs to be seen. So 160 to the base of 10. You have to think of how am I thinking of this trick. I just can't tell you that, okay, do this, you will get the answer. I have to tell you, how will you think about it? So all you need to think about is something is given to you, that is log of 2 to the base of 10. Now, any power of 2 can be very easily managed. And I know that 16 is a power of 2. So I know I can handle 16 very easily. The only troubling part is this 10, but I can get rid of it very easily. Why? Because the base is also 10. So why can't I quickly say that this 160 is 16 into 10? Which property do you recall now? Log of the product is log of the first one plus log of the second one. The base remains the same. Now, what is log of 16 to the base of 10? I can always write this 16 as 2 raised to power 4. This 4 will come down and it will just become 4 multiplied with the value which is given to you in the question. So that is the first part of the question. Now, what is the remaining part, which I was telling Tanishka that you have forgotten to note that? Log of 10 to the base of 10. Remember, we did this property as well. Log of 10 to the base of 10 is always 1. Why? Because when the number and the base matches, it has to be 1. So, of course, it comes out to be 2.204 because this part is 1.204 added with 1 makes it 2.204. Is that clear, everyone? Anyone still has a doubt? Very good. Let's move ahead. This question I'm not solving for you because we have done enough of the theory and I really think that you can easily solve this question. All you have to notice is a trick in this question. That is something that you should never miss out is there is a number which is getting repeated. JKL, JKL and JKL. So what should be done so that whenever you're dealing with fractions, remember when the denominator is same, it is very convenient for us. So I can do a trick in this question wherein only this same JKL remains here and the thing which is different goes up. And why am I thinking in that direction? See, what I'm trying to make you guys understand is that if I just tell you that, okay, solve this question like this, you will never remember it. You have to think, how do we think of a solution, right? So we think of a solution in a way that how can I make this equation look simple? So any fraction that is getting added with another one, getting added with another one can always be very simple only if the denominator is same. So the hint lies in the fact that this is to be retained in the denominator. This needs to be get rid of the denominator. What needs to be done to achieve that? Okay, another hint I'll give you. A property of log which says that log of a to the base of b can be written in a fraction form as log of A upon log of B with any base. So this is called as a base changing property. Log of A to the base B can always be written as a fraction log A upon log B. Now I think you should be able to answer it very quickly. Okay, so Tanishka says answer is 2. Anyone else has a different answer? Come on, guys. You guys also answer it. It's only Tanishka who is answering it. Harshit? I got few answers from you as well. Prem, Raj, Aviral, please answer. Okay, so how can you handle this question? Log of JKL to the base of log of JK. So what does that mean? I'm using that property that log of A to the base of B can always be written as log A upon log B. So how do we handle this question? Log of JKL to the base of JK. I know that this can be written as log of JKL upon log of JK, right? Similarly, the next one can be written as log of JKL upon log of KL. Similarly, the next one can be written as 1 upon log of JKL upon log of LJ. Now, obviously, these are fractions which can be written as this number will go up. So I'm changing it here itself. This denominator log JK will go up in the numerator. Similarly, this log of KL will get removed from here and go up in the numerator. And I'm sure by now you would have realized what's going to happen in the question. And this log of LJ will get removed from the denominator and goes in the numerator. So now we have made the denominator look same. So when you are adding 3 fractions and the denominator is same, all you have to do is keep that denominator as the LCM and just add the 3 numerators. When you add the 3 numerators, what do you observe? It is log of JK plus log of KL plus log of LJ, which is nothing but log of their product. So what is their product? It is going to give me a J square, a K square, and an L square. A power 2 on all of them can always be brought outside and taken in front as a product. So I remove the power 2 from all of them and just write it like this. Log of JKL, 2 comes in front to get multiplied. What do I get? The answer just becomes 2. That's it. Again, my tip to you is you are not going to solve this question like this. All you need to now remember is a shortcut for this question. How do you remember it as a short question? All you have to remember is when I look at this question, I have to just see in my memory what is going to happen. This JKL will retain in the denominator. The others will go in the numerator and they are getting added with logs. So if log of first, log of second, and log of third is getting added, I know it will become their product. And when I'm taking their product, I'm getting J square, K square, L square. So that power will come down and rest everything will cancel out. That's it. So you need to be this fast with these questions because all you have to always remind yourself, which is a common habit for a student of class 11th or 12th, is you start writing a lot of stuff because that's what you are habitual of. You have to tell yourself that it's not a school exam. It's a competitive exam. Nobody's bothered about my steps of calculations. All that is really important is finding the right answer, marking the correct option. Is that clear, everyone? Okay, let's move ahead. Solve this question. There are 2 logs in this question. So the shortcut has to be applied in such a way that you apply that property we discussed. When you are taking log of x to the base of y equal to z, it basically tells you something very important. What is that? Y raised to power z is equal to x. You will have to apply this concept 2 times in your question. That's where the shortcut lies. So Tanishka's answer is 4. So Tanishka, you mean to say option number 4 or 4 given in option number 2? Option 2. Very good. That is the correct answer. Anyone else got it? Okay, Ishita has answered it as 3, 4. There are 2 answers. So I think, Ishita, it is minus 3, 4 that you wanted to say. I think you missed out a minus there. Mayank, Piyush, Harshit, Prem, Raj, Aviral. Do you agree with the answer? Okay, let's look at the shortcut. What did I say about the shortcut? The shortcut is I will keep in my mind that I have a property which tells me that log of x to the base of y equal to z means a very simple thing. Y raised to power z is equal to x. Okay, Ishita. Now, let's see it here. First of all, call this entire thing as this x. The base y is 2 and the right hand side z is 1. So what can I say? This entire thing which I have encircled is my x. So this x is given by a particular method. What is that method? This entire x will be given by this number raised to this power. So what is 2 raised to power 1? It is 2. Now again apply this concept. This bracket is my x now. This 7 is my y now. And the right hand side z is 2 now. So this bracket n square minus n plus 37 will be equal to what? 7 raised to power 2. What is 7 raised to power 2? It is 49. Now you have a very simple quadratic to solve. That's it. And you all must be aware of how to handle a quadratic equation. So till here, the concept of log was applied. Now it is just a simple quadratic equation to be solved. So I repeat, how do you quickly handle such questions? You pick up the base from here, take the number from here, and what you need to do is 2 raised to power 1. What is 2 raised to power 1? It is 2. Now you are done with this log. You are done with this and the answer is 2. Now you handle the next log. In the next log, the base is 7 and the right hand side is 2. So all you have to do is 7 raised to power 2. What is 7 raised to power 2? It is 49. So you do the cutting here itself and you land up into this quadratic in just one go. That's how you have to handle the question. Okay. Now it's a quadratic, which is 37 minus 49 gives me a minus 12 here. And we all know that we need to factorize this quadratic, and the 2 factors that you're going to get from here are minus 3 and plus 4. Any one of them given in the answer will be my answer. So which of the following could be a value of n? 4 is the right one. So Ishita, you have to be careful. If you say 3, 4, then both the options become correct. Obviously, the roots are not 3 and 4. The roots are minus 3 and plus 4. We can never have like 3 is also there in the options, 4 is also there in the options, and both are my answers. That itself should have given you a hint that something has gone wrong. Is that clear, everyone? So now you are comfortable with multiple logs to be handled. Let's take another practice question and see how do you perform in this. So I'll come back to this slide. Let's look at this. Suppose you have 3 logs in a row. Log, log, and another log. Okay. And there is a bracket here. I'm not writing that bracket. All you have to tell me is what will be this bracket equated in the end. So there is a number 2 here. There is a number 3 here. There is a number 2 here. And the right hand side, suppose, is given as 2. Quickly tell me, what will be this bracket equal to when you finally get rid of all the logs? Tell me quickly. You don't have to simplify it. You can tell me it in the terms of powers also. That will also do. So Tanishka, you have to tell me ultimately 2 raised to power what? Answer your question as 2 raised to power what? So your question is find this x. Okay, you have to find this x. Very good, Tanishka. That's the correct one. So how do you handle the logs very quickly? As I said, the shortcut is keep cancelling the log. And all you have to do is take this number and take this in the power. So when you cancel the first log, you have 2 raised to power 2 becoming 4 on the right hand side. When you cancel the next log, you have 3 raised to power 4 becoming 81 on the right hand side. When you cancel the last log, you get x is equal to 2 raised to power 81. And that becomes your answer. Is that clear, everyone? So Ishita, very good. You two have given the correct answer. And Tanishka, you have also given the correct answer. Very good. Is that clear? So even if I have one more log, now you know how to handle it very quickly. So it's not that multiple logs are very complicated. No, it is not. You have to just remember the shortcut trick. The shortcut trick is remove the log by changing the right hand side. How do you change the right hand side? Take this number in the base and take the right hand side in the power. Whatever you get will be coming in the right hand side as a new right hand side. And that's what you keep doing till you get rid of all the logs in the question. Should we move to the next slide now? Now, in the next slide, I'm just going to discuss with you quickly, as in how you should be preparing and what all we have to offer to you. And then we will again come back to questions. So some of you were curious to know that what exactly is going to be the way you are going to prepare with us. So what we have for you is IPM online crash course in which you will be having 150 plus hours of live classes. So how are these live classes handled? Exactly the way it was handled today, with a lot of interaction, a lot of theory to be discussed first. So today we took up multiple topics because it was just an introductory class, but otherwise one class is dedicated for one particular topic wherein we discuss the theory, the concept, the shortcuts, and then we practice questions. And in practicing those questions, you can definitely ask for a repetition or you can ask for a doubt to be cleared up. We are always there to help you out, and the live sessions are always very, very interactive. So you learn a lot, but of course you need to participate. Then you will have 40 plus recorded concept videos. Now, what is the importance of these recorded concept videos? The recorded concept videos are like full of the basic concept. Then, as I told you a lot of times in today's session itself, once you are done with the basic concept, then you also need to understand the tricks and the shortcuts. So all these are recorded for you in the form of videos so that you can relook at it as many times as you want, so that you have a quick revision of all the concepts and they always remain with you in the form of recorded videos. You will be shared with 17 IPM and 100 plus other BBA entrance mock tests. Now, please mind it, mock tests are extremely important when you are preparing for these entrance exams. Why? Because when you take mock tests, you actually get your answer of how to prepare. Like everyone here must be thinking of how should I be preparing for this exam so that I get real successful. The answer and the secret lies in taking mock test. When you take a mock test, you get to know your weak areas and your strength areas. So for your strength areas, you further enhance them by taking advanced level questions, and your weak areas need to be brushed up with the very basic concept, because a weak area is a weak area not because the topic is difficult. Trust me, it's only weak because you have some concept which is not clear to you. So when you analyze your mock test, you get to know that which topic I really need to stress on and which topic I am very comfortable with, and it guides the way you should be studying. And it also helps you on that very day when you're taking the test. Why? Because when you've already identified your strength area, you will be in a position to decide this is the first category of question that I will be attempting, and my weak areas will be left for later on to be attempted. Because trust me, you will never be able to attempt the entire paper. So obviously you will have to be very pick and choosy in taking the right questions so that you quickly get the answer. The idea is that you solve 5 questions, and you get all the answers correct, but you end up picking the wrong questions in which half of them go wrong. Obviously, it is pointless to do that, right? You also have a very good advantage of having a Telegram discussion group, because what we normally observe is that when we are studying, we come up with a doubt, and we are studying at an odd hour where there is no one to help us out with that doubt, and we are badly stuck. So then your study comes to a halt. You're badly stuck. So then this discussion group is always going to be very helpful to you. You can always put up your doubts, and someone from our side will always be there to help you out within a limited time frame. So definitely this discussion group is advantageous for getting your doubts cleared, and also looking at the questions posted by others, because you get exposed to a new variety of questions which have been solved by others and they got stuck in that question. So you are lucky enough to come across a question which you did not solve, but yes, someone else solved it and got stuck. So you also get a lot of knowledge by others' doubts as well as your own doubts. So all this put together will definitely be more than enough for you to be very comfortable with the success in the exam, right? Moving ahead, as some of you were asking about the course details in terms of pricing and all, see the MRP of the course is definitely 29,999, and the link which is there on the screen right now, I'll just share it with you guys so that you can also go through the link. And when you go to the link, you will see that you will be aware, you can avail it at a discounted price, but the discounted price is further being brought down by 2,000 rupees additional for you. Why? Because you have attended this demo session. So when you use this coupon code mentioned to you on the screen, you will be availing it at a much discounted price of 17,999, which includes that additional 2,000 discount, which I mentioned to you. So obviously the pricing has been brought down for you. You can definitely make use of that. Now, coming down to what success we have had till now is obviously there on the screen right now for you. And these are some of our toppers. And I really wish that you also see your picture next year here. And for that, of course, you would be coming up with queries like, what I really need to do if I really want my picture to be here next year. So the point is, it's very simple. When you are preparing for this exam in a complete whole, so all you need to know is there are steps for preparing. The first step, as I said, whenever you're picking up a topic, pick it up from the scratch, wherein you handle the concept, the very basic concept which deals with that topic. Then go ahead and solve practice questions. When you solve practice questions, you get further clarity of, are you really good in that topic or not, right? Then start taking mocks. When you start taking mocks, you get to know for yourself without anyone's assistance that what exactly you need to prepare. And finally, when you find out your weak areas and you work on it and again take the next mock, it gives you an additional knowledge of, have I improved in that topic? If the answer is yes, good enough. If the answer is no, then you really need to study it again. And for all this assistance, we will always be there to help you out, right? So the number mentioned on the screen and the email ID mentioned on the screen is there to help you out for any further queries that you have. But I'm still here to clarify any of the doubts that you have. Anyone wants any clarity till here? If you have no questions to ask, then we can definitely go ahead with the next topic. We can quickly do one more question. So all those who are interested in finding about the details of the course, I think you have got the information. If you have any query, please ask it right now. Otherwise, I can move to the next topic and we can do one more question. Say yes or no. What do you want? You want another question or you want to ask some doubts? Question. Okay, let's move on to one more question. This question is from matrices. How many of you are aware of matrices? If not, let me just tell you that matrix multiplication, I'm just telling you in short to those who are not aware of it. A matrix multiplication, like you multiply numbers like 7 into 3, right? So when you multiply two numbers, you just multiply them. There is no condition that can you multiply them or not. But in matrices, there is a condition. When you are multiplying two matrices, they have a condition that the first one has an order m cross n. What is this order? The number of rows is m, the number of columns is n. Then the order of the second matrix has to start with this number n and can end in anything. So the condition for two matrices to get multiplied is the number of columns in the first one should match with the number of rows in the second one. Keeping this condition in mind, your question is saying that I can find AB also, I can find BA also. Both the products are defined for you. You are told that the order of A is m cross n. So what should be the order of B? Now, with the first condition, I know that the order of B has to start with n and can be anything else. But BA is also defined. So what is the order of B? It is n cross something which I don't know. But the order of A is given in the question as m cross n. And I know that this product will be possible only when these two numbers match. So I get to know this missing number also. It has to be m. Now, once you have understood it as a concept, now just learn it as a shortcut. What is the shortcut? If there is a matrix A given to you, which is of the order m cross n, your question says that I'm looking for the order of matrix B such that AB is also possible, BA is also possible. You have to just reverse this order to find the order of B. So if the order of A is m cross n, as Ishita has already answered it, the order of B has to be n cross m. So the right answer is option number 2. Is it clear, everyone? So that's how you remember it as a shortcut, that the answer for the order of the second matrix has to be just reverse of the order of the first one. That's it. So this shortcut makes you solve it very quickly, even without knowing the too much of detailing of matrices. Everyone clear? Okay. Now, let's move to another very simple question, this one. Let me see how many of you answer it correctly. And for those who don't know matrices, let me just give you a hint. For solving this, you are looking for A inverse, A raised to power minus 1. So just simply multiply the left hand side as well as the right hand side with A raised to power minus 1. So do that. If you're not aware of which theorem this question is talking about, if you have not taken math in 11th and 12th, you might not be aware of matrices right now, but use the hint which I'm giving you. Multiply both sides with A raised to power minus 1. So of course, like you have x raised to power minus 1 and x raised to power 5, what happens? It becomes x raised to power 4. Similar thing happens for matrices also. If there is a negative power and there is a positive power, it will bring down the power by that number. Okay, so Ishita says option number 1. Anyone else has a different answer? Harshit, Prem, Raj, Aviral, Piyush, any other answer? Okay, Prem also says option 1, Raj also says option 1, and option 1 is the most commonly given wrong answer. It is not correct. Think why. There is something missing in the option number 1 which is making it wrong. You have to tell me what is it. Something is typically wrong in option number 1. What is that? When you multiply A inverse inside on the left hand side, what happens? It becomes 3A square, 2A raised to power 1, 5 times A raised to power 0. Now, what you notice is that A multiplied with A inverse is not like nothing there. The concept of matrices tells you that if you have A multiplied with A inverse, don't think that you don't have anything there. It is identity matrix. So if you are aware of the concept of matrices, which we have not discussed in today's class in that much of detail, but if you are aware that you must be knowing that A into A inverse is not 1, it is identity matrix. So this is missing in option number 1. Do you realize that? A inverse multiplied with identity is A inverse itself. So identity is basically what is like 1 for numbers. 1 into 7 is 7. Similarly, identity into any matrix is that matrix itself. So what is this A inverse? A inverse is minus of 3A square plus 2A plus 5I. What is missing in the option number 1 is I. It is in fact missing in every option. It is deliberately given like that so that you end up marking option number 1 as the correct answer. And most of the people do this mistake. They think that option number 1 is correct, and they have deliberately put it in option number 1 so that you end up marking it. Whereas it is not the correct answer. The correct answer is none of these, because this is the correct answer, which is not there in any of the options. Is it clear? So be very careful about this. Numbers tell you that if you have 7 into 7 raised to power minus 1, it is just 1. But matrices tell you that if you have A into A inverse, it's not 1. It's something called as identity matrix. Are you all clear? So matrices questions are like this. The options are tricky. You all know the concept, but even then you make silly mistakes of marking the wrong answer because you miss out on very simple things. And where they will try to confuse you is always with numbers. Okay, they will try to do something related with numbers that you miss out. Please remember, numbers and matrices behave little bit different. Okay, there you have 1, here you have identity, there you have 0, here you have null matrix. So they have slight differences. Anyone has a doubt with this question? So I'm taking you back to the previous slides wherein the details of the course is there. If you still have any queries, you can definitely ask me. Otherwise, we are done with the questions. Anyone wants to know anything from me? And for further details, you can definitely write on this email ID, and you can definitely make a call at this number if you still have any questions that come up to you later. All right, then. Okay, then. That's it from my side. Goodbye, everyone. Take care and all the very best for your future. Thank you very much. Thank you, Ishita.